We live on Earth's hard, rocky surface. Breathe the air that surrounds the planet. Drink the water that falls from the sky. And eat the food that grows in the soil. But Earth did not always exist within this expansive universe, and it was not always a hospitable haven for life. Billions of years ago, Earth, along with the rest of our solar system, was entirely unrecognizable, existing only as an enormous cloud of dust and gas. Eventually, a mysterious occurrence, one that even the world's foremost scientists have yet been unable to determine, created a disturbance in that dust cloud, setting forth a string of events that would lead to the formation of life as we know it. One common belief among scientists is that a distant star collapsed, creating a supernova explosion, which disrupted the dust cloud and caused it to pull together. This formed a spinning disk of gas and dust, known as a solar nebula. The faster the cloud spun, the more the dust and gas became concentrated at the center, further fueling the speed of the nebula. Over time, the gravity at the center of the cloud became so intense that hydrogen atoms began to move more rapidly and violently. The hydrogen protons began fusing, forming helium and releasing massive amounts of energy. This led to the formation of the star that is the center point of our solar system, the Sun, roughly 4.6 billion years ago. How did the Earth form? The formation of the Sun consumed more than 99% of the matter in the nebula. The remaining material began to combine into various masses. The cloud was still spinning, and clumps of matter continued to collide with others. Eventually, some of those clusters of matter grew large enough to maintain their own gravitational pull, which shaped them into the planets and dwarf planets that make up our solar system today. Earth is one of the 4 inner, terrestrial planets in our solar system. Just like the other inner planets, Mercury, Venus, and Mars, it is relatively small and rocky. Early in the history of the solar system, rocky material was the only substance that could exist so close to the Sun and withstand its heat. Infant Earth, at its beginning, Earth was unrecognizable from its modern form. At first, it was extremely hot, to the point that the planet likely consisted almost entirely of molten magma. Over the course of a few 100 million years, the planet began to cool and oceans of liquid water formed. Heavy elements began sinking past the oceans and magma toward the center of the planet. As this occurred, Earth became differentiated into layers, with the outermost layer being a solid covering of relatively lighter material while the denser, molten material sunk to the center. Scientists believe that Earth, like the other inner planets, came to its current state in 3 different stages. The first stage, described above, is known as accretion, or the formation of a planet from the existing particles within the solar system as they collided with each other to form larger and larger bodies. Scientists believe the next stage involved the collision of a protoplanet with a very young planet Earth. This is thought to have occurred more than 4.5 billion years ago and may have resulted in the formation of Earth's moon. The final stage of development saw the bombardment of the planet with asteroids. Earth's early atmosphere was most likely composed of hydrogen and helium. As the planet changed, and the crust began to form, volcanic eruptions occurred frequently. These volcanoes pumped water vapor, ammonia, and carbon dioxide into the atmosphere around Earth. Slowly, the oceans began to take shape, and eventually, primitive life evolved in those oceans. How do we know? The key is meteorites. Meteorites bring many different types of material from all over the solar system to Earth where scientists can study them. These materials include chondrules, tiny pieces of dust and rock that have survived from before the planets formed, and pieces of asteroids and planetesimals left behind by the planet-building process. Radioactive elements like uranium and hafnium are trapped inside the minerals that make up these objects when they form, which allows planetary scientists to tell how old they are. Using these measurements, and simulations of the physics of dust and planetesimal collisions, planetary scientists and astronomers have established that the dust-to-protoplanet process takes tens of millions of years. But the final stage of planet formation in our solar system may have taken much longer, up to 100 million years or so. This was not only the last major addition of material to the Earth, but also the event that formed the Moon. and it's one of the most debated parts of the story. Volcanoes, mountains, tectonic plates, and an evolving Earth. The oldest surviving rocks on Earth were laid down some 500 million years after the planet first formed. It and other planets suffered through what's called the late heavy bombardment of the last stray planetesimals around 4 billion years ago. The ancient rocks have been dated by the uranium lead method and appear to be about 4.03 billion years old. Their mineral content and embedded gases show that there were volcanoes, continents, mountain ranges, oceans, and crustal plates on Earth in those days. Some slightly younger rocks, about 3.8 billion years old, show tantalizing evidence of life on the young planet. While the eons that followed were full of strange stories and far-reaching changes, by the time the first life did appear, Earth's structure was well formed and only its primordial atmosphere was being changed by the onset of life. The stage was set for the formation and spread of tiny microbes across the planet. Their evolution ultimately resulted in the modern life-bearing world still filled with mountains, oceans, and volcanoes that we know today. It's a world that is constantly changing, with regions where continents are pulling apart and other places where new land is being formed. These actions affect not just the planet, but life on it. How did the moon form? Several different formation theories for the moon have been proposed by scientists. The story that is best supported by all the available data, however, is that the moon formed during a giant impact between the proto-Earth and another protoplanet roughly the size of Mars, sometimes known as Theia. In this theory, the moon formed from the impact debris, a mixture of molten rock and hot gas, flung out into space by the impact, potentially forming a disk of material known as a lunar synestia. Samples of rock from the moon, brought to Earth by lunar meteorites and the Apollo moon landings, can be used to understand the history of the moon and its relationship to the Earth through the chemistry of their minerals. Thanks for watching. If you liked the video, press the like button. Subscribe our channel to support us and press the bell icon to get the next video notification. See you in next space adventure.